Hi friends, in this video we are going to discuss about star delta starter. In star delta starter, for example, this is my induction motor and supply mains. For example, this is my star. Initially, the machine connected to the star. Initially, the machine connected in star connection. Then during running condition, the machine should be connected in delta. Delta nothing but generally delta connection. Delta connection nothing but, for example, this is R phase, R dash, Y dash, B dash. Delta connection. Nothing but the R dash connected to Y dash connected to B dash connected to R. Nothing but this R should be connected to, this is R dash, Y dash, B dash. R is connected to B dash. R is connected to B dash. Should be connected to B dash. R connected to B dash. Next one, the Y connected to R dash. Y connected to R dash. Y should be connected to R dash. Y should be connected to R dash. Y should be connected to R dash. See here. Y should be connected to R dash. And next one, B should be connected to Y dash. 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 Like this. For example, my B should be connected to Y dash. And this is another terminal. And this is another terminal. This is the connection. Of course, here we have a switches. Here also we have a switches. This is simply the star delta connection. Once they asked already, what is the switch? What is the switch? The switch having three polarities. That's why triple pole. How many throughs are there? One through for star, another through for delta. So double through. TPDT switch. This switch is called as TPDT switch. TPDT switch, and this is the star delta starter. Okay, now let's go for. Actually, here we have a star connection and delta connection. Initially, the machine should be connected in star or delta. Where should I connect? See here. For example, here I phase is equals to V phase by Z phase. Here also I phase is equals to V phase by Z phase. What is I phase here? I phase is equals to V phase is equals to, in line, V phase is equals to, in star connection, V phase is equals to VL by root 3 into Z phase. Whereas in delta connection, V phase is equals to V line by Z phase. Once check it, where the current is less, where the current is more. See here current is VL by Z phase, but here current is VL by Z phase divided by root 3. Yes or no? Yes or no? See here, this I phase can be written as, the I phase in star connection is equals to 1 by root 3 into the I phase in delta connection. Yes or no? I phase in delta connection. This is I phase in star, this is I phase in delta. So the I phase in star connection is equals to just 57.7% of I phase in delta connection. I phase in star connection is equals to 1 by root 3. 1 by root 3 nothing but 57.7% of I phase in delta connection. I phase in delta connection. So the current is less in star. That's why initially motor connected in star. But at running condition, the motor connected to the delta. At running condition, motor connected to the delta. Initially, the motor connected to the star, because in star, the phase current is just 57.7% of delta, less value. That's why this is connected here. See clearly, this is very important. Right, sir. Now see here, line currents. What is the line current in star? In star, the line current is equals to phase current. In star, line current is equals to phase current. So line current in star is equals to VL by root 3 into Z phase. VL by root 3 into Z phase. Yes. What is line current in delta? Line current in delta is equals to root 3 times of phase current in delta. Root 3 times of phase current in delta. So now tell me, the line current in delta is equals to root 3 into VL by Z phase. VL by Z phase. The line current in delta is equals to root 3 times of phase current in delta. You know already. Now tell me, what is the ratio of line current to the star to the line current to the delta is equals to? Line current to the star to the line current in delta is equals to, what is the value here? VL by root 3 into Z phase divided by root 3 into VL by Z phase. Root 3 into VL by Z phase. This VL by Z phase is cancelled. The value is 1 by 3. Very, 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 very important. So, the line current in star to the line current in delta is equals to 1 by 3. Line current in star to the line current in delta is equals to 1 by 3. Line current in star to the line current in delta is equals to 1 by 3. Yeah, this is very important. Okay, completed up to here. What I done? Completed up to here. Now see one's diagram clearly. Okay, this is my diagram. Okay, now I am taking to calculate the torque also. Right, I'm removing this. Now I want the starting current of star delta to the starting current of DOL is equals to the starting current to the star delta, nothing but the starting current to the star only. The starting current to the star delta, nothing but starting current to the star. What is the starting current to the star? VL by root 3 into Z phase. VL by root 3 into Z phase divided by the starting current to the DOL, nothing but the current to the delta. The current to the delta, nothing but root 3 into VL by Z phase. Again, these two gets cancelled out. So, starting current to the star delta is equals to 1 by 3 times of the starting current to the DOL. Starting current to the DOL. Very, 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 very important. Starting current to the star delta is equals to 1 by 3 times of the starting current to the DOL starting. Because starting current to the star delta, nothing but starting current to the star. Starting current to the DOL, nothing but directly connected. Directly where connected? In delta. There is no star. Directly connected to delta. What is delta current? This is my delta current. Now we have another starting torque to the full load torque is equals to S full load into what is the current taken by the motor? The current taken by the motor is IST by root 3 only. If this is IST by root 3 current taken by the motor. Divided by what is the full load current? Generally the full load current is whole square. Now tell me, what is the answer? The starting torque to the full load torque is equals to 1 by root 3 square, 1 by 3 into slip rate full load into IST by I full load whole square. So the starting torque in star delta starter is equals to 1 by 3 times of the starting torque in DOL starting. We have to compare all with DOL, because in DOL we are not using any starter, but by using starter, how much torque we can control? 1 by 3 times. By using star delta starter, we can control current also 1 by 3 times. These two are very important. Starting torque in star delta, starting current in star delta, both are 1 by 3 times. These derivations are important. You have to remember. This is most important. These two are the most important. Then after this one also most important. This one also most important. Then after this one. Totally, this is equation 1 very important, equation 2 very important, and equation 3 very important, and equation 4 very important. These 4 equations are very important. You have to remember. Yes, okay. Starting current in star delta starter, starting torque in star delta starter, the phase current in star to the delta, line current in star to the delta. See once clearly. Okay, next fifth one, rotor resistance control starter. Generally, the rotor resistance control starter only applicable for slip ring induction machine, because we cannot control the rotor resistance of squirrel cage induction machine. In rotor resistance of slip ring induction machine, if rotor resistance increases, the rotor current reduces. If rotor current reduces, automatically stator current also reduces. If rotor current reduces, automatically stator current also reduces. So only in slip ring induction machine, by adding extra resistance through the slip rings, we can increase the rotor resistance. If rotor resistance increases, rotor current reduces. If rotor current reduces, the stator current also reduces. Like that, we can control the starting current reduces. But this is not applicable for squirrel cage induction machine. And next one, generally DOL starting, stator resistance control starting, and auto transformer starting, and star delta starters. These 4 are generally used for squirrel cage induction machines only. These 4 are generally used for squirrel cage induction machine, and the 5th method is generally used for slip ring induction machine. Right. This is completely what are the starters. About starters. Now some problems on starters. How they will ask you problems. Let's see here. First one, first formula, starting torque to the full load torque is equals to slipped full load into IST by I full load whole square. First formula. And next one, generally in DOL starting, if the current is IST, torque is TST. Now, the stator resistance control, the current controlled X times and torque controlled X square times. Very important. And in auto transformer starter, current controlled X square times and torque controlled X square times. And in a star delta starter, current controlled 1 by 3 times and torque also controlled 1 by 3 times. This is generally the formulas we have to remember. Right. First question. At what percent of tapping? Auto transformer starter acts as star delta starter. At what percent of tapping auto transformer starter acts as star delta starter? Can you tell me? What I told you, the auto transformer starter acts as a star delta starter. Take any one. For example, auto transformer starter x square times of ist, but star delta starter 1 by 3 times of ist. ist cancel. X square is equal to 1 by 3. Okay. X square is equal to 1 by 3. So x is equals to 1 by root 3. X is equals to 1 by root 3. Nothing but 57.7 percentage. 57.7 percentage of tapping. The auto transformer starter is exactly equals to star delta starter. At what percent of tapping? Auto transformer starter acts as a star delta starter. 57.7% of tapping. The auto transformer starter acts as a star delta starter. This is the first question. Next, the second question. See here, my second question. Second question. For example, when the induction motor started by DOL starting, starting current is 10 amperes, starting torque is 100 Newton meters. 100 Newton meters. Are you okay? Induction motor started by DOL starting current is 10 amperes, starting torque is 100 Newton meters. If same motor started by auto transformer starter, same motor started by auto transformer starter with 80% of tapping, 80% of tapping, then starting current and starting torques are, induction motor started by DOL starting current is 10 amperes, starting torque is 100 Newton meters. If same motor started by auto transformer starter with 80% of tapping, then starting current, starting torques are the question. So the given x value, x is equals to 80%, nothing but 8 by 10. Right. Next one. The starting current in auto transformer starter is equals to x square times of the ist in DOL starting. We know this. What is x square? X square, 8 square by 10 square, 64 by 100 into starting current 10 gets cancelled. Answer is 6.4 amperes. Answer is 6.4 amperes. That's very good. What is the starting torque in auto transformer is equals to x square times of the starting torque in DOL is equals to 8 square 64 by 10 square 100 into the starting torque in DOL 100. So answer is 64 Newton meters. 64 Newton meters. This is the second question. And next question. Induction motor started by DOL starting, then starting current is 30 amperes, starting torque is 150 Newton meters. 150 Newton meters. If same motor started by star delta starter, then starting current is equals to starting current in star delta is equals to 1 by 3 times of the starting current in DOL, that is 1 by 3 into 30, that is 10 amperes. 10 amperes. Yes or no? Very simple answer. Next one, starting torque in star delta is equals to 1 by 3 times of the starting torque in DOL is equals to 1 by 3 into 150 is equals to 50 Newton meters. 50 Newton meters. These are the three questions. Very simple questions. What is first question? At what percent of tapping? Both are same. 57.7. And DOL starter to the auto transformer starter. And DOL starter to the star delta starter. DOL starter to the star delta starter. These are the questions they are asking. The starting current in star delta is equal to 1 by 3 times. Starting torque 1 by 3 times. Starting current x square times. Starting torque x square times. Right? Next question. An induction motor started by auto transformer starter at 40% of tapping. Then its torque 200 Newton meters. If the same motor started by same auto transformer starter, same starter at 80% of tapping, then torque is equals to, starting torque is equals to. The question is that induction motor started by auto transformer starter at 40% of tapping, then its starting torque 200 Newton meters. If the same motor started by same starter at 80% of tapping, what is the starting torque? The starting torque is directly proportional to x square. Nothing but the starting torque in second time by starting torque in first time is equals to x2 square by x1 square. Now tell me, starting torque in second time is equals to first time 200 Newton meters into x2 square, 80% into 80% by x1 square, 40% into 40%, 40% into 40%. Then starting torque at 80% of tapping is equals to 4 into 2. 800 Newton meters. 800 Newton meters. At 80% of tapping, the torque is 800 Newton meters. 800 Newton meters. Right? This is the question they are asking. This is the question. Right. Next question. See here. Next question. A three-phase 50 Hz, 6-pole slip ring induction motor rotating at 900 rpm, and starting current is 5 times of the full load current. Starting current is 5 times of the full load current. Then find out full load torque to the starting torque ratio. Tell me the answer fast. Hold the video and do the question. Okay. Completed. Let's see. Actually, we have a formula. Starting torque to the full load torque is equals to slipped full load into starting current to the full load current whole square. This is the formula. Now, this formula, what is the slipped full load? See, this is 6-pole 50 Hz machine. Nothing but 1000 RPM synchronous speed. Synchronous speed 1000, rotor speed 900. So slip is 10%. 10% into I starting torque. They given starting current. Starting current 5 times of the full load current. 5 times of the full load current by full load current whole square. Full load current gets cancelled out. Full load current gets cancelled out. And 0 gets cancelled out. 0, 0 gets cancelled out. So what is the answer? What is the answer? This is 5 square. So 5 square nothing but 25 by 10. So this is what the starting torque to the full load torque ratio, nothing but 5 by 2. 5 by 2. But they asked you the question full load torque to the starting torque ratio. What is the answer? You got starting torque to the full load torque 5 by 2. But they asked you full load torque to the starting torque. The answer is 2 by 5. 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 What they given? 50H 6 pole. Synchronous speed is 1000. And rotor speed is 900. So slip is equals to 1000 minus 900 by 1000, nothing but 100. 100 by 1000, nothing but 10%. 10%. Okay, slip. What they given? Starting current is 5 times of the full load current. Starting current is 5 times of the full load current. Full load current is full load current. Full load current cancel. 5 square 25 and 10. 5 by 2. 5 by 2 can be written as 2 by 5 because they asked full load torque to the starting torque. Very, very, very important. Don't miss. This is the another type of question. Right? These are the questions they are asking in starters. Once you see.